Hello everyone, today's topic is Cauchy Reimann equation. So the equations del u by del x equals to del v by del y and del u by del y equals to minus of del v by del x, these two equations are called Cauchy Reimann equations. And for finding f dash z0, we will use this formula, that is f dash z0 is equals to del u by del x plus I del v by del x. Now let us see this question where we are asked that if this function satisfies the Cauchy Reimann equations or not. Okay, so here f of z is equals to x square minus y square plus I into 2xy. Alright, so this is uxy and this one is vxy. Fine. Now we will find del u by del x, can also be represented by ux, which is equals to 2x. Fine. And then we will find del u by del y, which is equals to how much? Minus 2y. Then we'll find vx, which is 2y, and vy, which is equals to 2x. Now according to the Cauchy Reimann equation, vx must be equals to ux must be equals to vy. So here from this we can see that these two are equal. So yes, the first equation is satisfied. Second equation says that del u by del y must be equals to minus of del v by del x. So now this one, this two, see, yes, it's also satisfying. This is equals to minus of del v by del x. So yes, both the equations are satisfied over here. Now in this slide we can see the Cauchy Reimann equation for polar coordinates. Now let us check whether for this function the Cauchy Reimann equation satisfies or not. Okay, so if f of z is given by 1 by z, which is equals to 1 by r e to the power I theta. Fine. If we take this up, then this will become e to the power minus I theta. Now e to the power minus I theta, its value is, see, just because here minus sign is there, so we will take here minus, that is cos theta minus I sin theta. Z can be written as e to the power I theta, which is equals to cos theta plus I sin theta in complex analysis. Fine. So now here we can see that u r comma theta is equals to cos theta by r, and v r theta is equals to minus sin theta by r. Okay, now we will find u theta, which is equals to minus sin theta by r, and v theta is equals to minus cos theta by r. Then next let us find del u by del r, which is equals to minus 1 by r square into cos theta. Alright, and then let us find del v by del r, which is equals to minus of minus 1 by r square into sin theta, which is equals to 1 by r square sin into sin theta. Alright, now according to the Cauchy Reimann equation, r into del u by del r is must be equals to this del v by del theta. This is 1, and del u by del theta must be equals to minus of r del v by del r. Okay, so if these two equations satisfy, then we can say that yes, Cauchy Reimann equation satisfied for this particular function. So now let us check whether these two equations are satisfied or not. See here, del u by del r is equals to minus 1 by r square cos theta. Let us see whether we can write this in this form or not. R into minus 1 by r square cos theta, which is equals to, now this is equals to minus of cos theta by r. Alright, so on cancellation we can see that the LHS and RHS both are equal, so this first equation is satisfied. Next, let us check whether this one is satisfying or not. That is, del u by del theta is how much? Del u by del theta is minus sin theta by r. Alright, which is equals to minus r into del v by del r. Del v by del r is 1 by r square sin theta. Fine, and now on cancelling r, we can see that the LHS and RHS both are equal. So this equation 2 is also satisfied. Hence the Cauchy Reimann equation is satisfied. Now let us see what is analytic function. A function f is analytic in an open set if it has a derivative everywhere in that set. Next, entire. An entire function is a function that is analytic at each point in the entire complex plane. And the point at which the function does not exist is called the singular point. For example, when f of z is equals to 1 by z, then at z equals to 0, the function does not exist. So here z equals to 0 is the singular point. So, if two functions are analytic in a domain D, then their sum and their product both are analytic in the domain D. Similarly, their quotient is also analytic in the domain D, provided that the function in the denominator does not vanish at any point in D. And here is a point from the theorem that if f dash z is equals to 0 everywhere in the domain D, then f of z must be constant throughout D. So now here is an example from entire function. So if a function is analytic in at every point in the complex plane, then it is said to be entire. Alright. So now let us see what is harmonic function. A real valued function h is said to be harmonic if it satisfies the Laplace equation. And if a real valued function is analytic in a domain D, then its component functions u and v are harmonic in the domain D. Now, if two given functions u and v are harmonic in a domain D and their first order partial derivatives satisfy the CR equation, then v is said to be the harmonic conjugate of u. So now here is a question from harmonic function. If f of xy is equals to uxy plus ivxy is an analytic function, then we need to show that u is harmonic and we need to find its harmonic conjugate. Alright, so now if this u satisfies this harmonic equation, then it is harmonic. So let us find del u by del x, that is equals to minus 6xy. Again, this is equals to minus 6y. Now del u by del y is equals to 3y square minus 3x square, and this is equals to 6y. Okay, now when adding this two, we will get 0, isn't it? So it satisfies the Laplace equation, so it is harmonic. Next, we need to find its harmonic conjugate. So now for finding the harmonic conjugate, first we know that it is already analytic. Okay, so it will satisfy the Cauchy Reimann equation, that is ux equals to vy and del u by del y is equals to minus of del v by del x. So now this del v by del y is equals to how much? Minus 6xy. Now first we will integrate this with respect to y, which will give us vxy is equals to minus 6xy square by 2 plus 5x. This is a constant. Okay, we will take this constant So we have assumed that let this be a function of x. Fine. So now next we will differentiate this with respect to x. Means we will differentiate this partially. Okay, that is partial differentiation. So del v by del x is equals to minus 3y square plus 5 dash x. Alright, now we know that del v by del x is equals to how much? Minus of uy, that is this much, minus 3y square plus 3x square, which is equals to minus 3y square plus 5 dash x. Now from here this we will get 5 dash x is equals to 3x square. Alright, now we will integrate this with respect to x to get this as 5x is equals to 3x cube by 3 plus c. So we got from here 5x. Alright, now we will evaluate this value in this equation. Okay, let me name this as equation 1. So now vxy is equals to minus 3xy square plus 5x. 5x is how much? X cube plus c. So this is the harmonic conjugate of u. Okay.